Example 8. Find the absolute maximum, absolute minimum of this function on the interval from 0.5 to 10, bracketed again. And again, we have three criteria. So immediately, 0.5 and 10 are critical numbers because they're endpoints. The other criteria we require is a first derivative. So if I go f prime of x equals, I've got 2x obviously for this first one. That's easy enough. This is 20x to the negative first, right? That term, getting it in power structure. So if it's 20x to the negative first, it's going to be minus 20x to the negative second is going to be its first derivative. Keep in mind we're subtracting 1 from the power. Negative 1 minus 1 is negative 2. So be careful about negative powers that you're subtracting, but you're subtracting from a negative, so we actually add the two absolute values of the numbers. So that's my first derivative. And again, my goal is to set that equal to, well, let's just look at it in this 2x minus 20 over x squared. Okay, I want to set that equal to 0, right? To find out where it equals 0. If I multiply by x squared to get rid of the fraction, I'm going to get 2x cubed minus 20 is equal to 0. Now, cubic function, we don't have any kind of cubic formula that you've learned yet. But there is no other terms except a linear term, so just getting the linear term isolated. So 2x cubed equals 20, dividing both sides by 2. And then we take the cube root of 10. I don't have any idea what the cube root of 10 is off the top of my head, so I'm going to go to my calculator. Anytime you need to do a root, it's not a square root, you go to the math menu. Cube root's right there, number 4. Any other root, the x root button is used. So cube root of 10, and we can go 2.1544. Also, 10 caret parentheses 1/3. That's another way to do a cube root. Any root for that matter, fifth root to the 1/5 power. Just make sure that the root itself, the power itself, goes in parentheses there. So 2.1544. And 2.15 is within that interval, so it counts, right? So I'm going to put x equals 2.15 for that one.
What if it didn't count?
Then you don't use it. So if I got x equals 17, it doesn't matter.
Okay.
All right. So again, if it's not within the interval, we only care about numbers within this interval. So if they're not within the interval, they don't matter. So just don't write them down. Okay. And on that note, looking at the undefined, this function here is the derivative, right? It's undefined when x equals 0, right? So this undefined part would be x equals 0, but 0 doesn't live on that interval, right?
Oh yeah.
So it doesn't count. All right. So if a number does not exist if the number is not within that interval, even if it does fit the criteria for a critical number, it's not a critical number within this interval, so we don't care about it. All right. So do a little scribble rule there. Make it go away. That was a scribble rule. If you didn't hear that scribble rule, scribble out things that don't count. F of 2.15 equals something, f of 0.5 equals something, and f of 10 equals something. It was 1.5, not 5.1, right? Yeah, 1.5. Good. Good. For some reason I was thinking 5.1 in my head, and I kept writing 1.5, and I thought maybe I was doing it backwards. So, all right. So now, what do we want to evaluate?
The original function.
The original function. So I want to evaluate this thing for these three numbers to establish the biggest and the smallest values. So I'll go back to my y equals, clear out what's in there, and I type in x squared plus 20 divided by x, and I go to my table, delete all the stuff I got in there because I got new critical numbers, 2.15, 0.5, and 10, and we get 13.93. We get 40.25, and we get 102. All right, so looking at the three answers, three results there, let me just take this stuff and shrink it up a little bit. That's the smallest, right? And that's the biggest? So again, once you get the values, just compare the numbers. The smallest number, the biggest number, the ones we're looking for, because we're looking for the absolutes. We don't care about locals, we want absolutes. So I know that absolute minimum of 13.93 at x equals 2.15, an absolute maximum of 102 at x equals 10. Alright. If you want to be a tad bit more accurate, if I, instead of going 2.15, I actually did the cube root of 10. Goes all the decimal places. It still gets the same 2 decimal place approximation, and well, 13.92 instead of 93. But, you know, cube root of 10 instead of 2.15. A couple decimal places is sufficient to me. I don't think we need to go beyond that. All right, so there you go for that one.